Welcome to aminacademy.com. In complex analysis regarding complex functions, let us solve some problems. Example, show that modulus of sin z whole square equal sin x whole square plus sin hy whole square, where z equal complex number x plus iy. Now, sin z whole square equal LHS equal substitute z as x plus iy, that is sin of x plus iy the whole square, which is equal expanding sin x plus sin a plus b, that is modulus sin x cos iy plus cos x sin iy the whole square equal the modulus of this sin x cos iy plus cos x sin iy is equal sin squared x cos iy, we can write cos hy, that is square, plus cos x sin iy is sin hy. I sin iy is sin iy is of I sin, here it comes I square sin squared y, sin h squared y. Here, because here sin iy we can write as sin hy. Therefore, the square is sin h square y into I squared. So, further equal sin squared x cos h squared y here already minus, so I squared is minus 1, so it's plus 1 cos x into, that is cos squared x into sin h squared y. Now, therefore, we can write sin squared x here cos h squared y we can write as 1 plus sin h squared y, and cos squared x we can sin h squared y we can write as, then write as it is first sin h squared y. Now, sin squared x plus cos squared x plus sin squared x into sin h squared y, which is equal sin squared x, and cos squared x plus sin squared x is 1, then plus sin h squared y. So, which is further equal sin x the whole square plus sin h y the square, which is RHS. We start with LHS. We proved LHS equal to RHS. Therefore, LHS equal RHS, hence proved. Next, show that modulus of cos z whole square is equal cos squared x plus sin hy whole square. For all z is element of complex number where x equal real part of z and y is imaginary part of z. Now LHS cos of z the modulus square, which is equal cos of x plus iy the square, which is equal cos a plus b whole square is cos x plus cos of yi iy you can write minus sin x into sin iy, that whole square. Here the modulus square equal we can write as cos squared x into cos iy is cos of hy the square plus sin squared x into sin hy because sin iy is I sin y, sin hy, therefore here minus I square comes, then which gives further cos squared x cos of h square y, I square is minus 1 but minus 1 is there, so it is plus sin squared x into sin h squared y. Now cos squared x 1 cos h squared y is 1 plus sin h squared y plus sin squared x into sin h squared y hyperbolic y. Now further this is expanded cos squared x plus cos squared x plus sin squared x sin of h squared y, which is equal cos squared x. Here cos squared x plus sin squared x is 1, so 1 into sin h squared y is sin h squared y. So here we can write this one as cos x the whole square plus sin h the whole square equal RHS. LHS equal to RHS, hence proved. Here, third problem. Example, find all complex roots of cos z equal to 3. Here, first cos z is can be written as e power iz plus e power minus iz by 2. it comes down to solve, like, which is therefore e power iz plus e power minus iz equal 2 into 3 is 6. So let e power iz equal to w, then you can write w plus w power minus 1 equals 6. So which is w plus 1 over w equals 6. Multiply throughout by w, we get w squared plus 1 equal 6w, which further gives w squared minus 6w plus 1 equal to 0. Therefore, then we can say if w equal to e power iz, the roots of w squared minus 6w plus 1 equal to 0 are 3 plus or minus 2 root 2 by solving, say, w squared minus 6w plus 1. Therefore solutions are solutions for cos z equal 3 are iz equal log of 3 plus or minus 2 root 2, because w equal to e power iz we let, then which implies we have, therefore z we can write minus I of ln of 3 plus or minus 2 root 2 plus 2 n pi I, which gives 2 n pi I minus, because we are multiplying with minus I throughout here, I into ln 3 plus or minus 2 root 2 for n is integers. For n is integer. We have done. Please subscribe our YouTube channel.